Recording is on.
Okay, so yeah, where do we start? So first, we need to know where actually is the code that does the text formatting and layout. So the text formatting, which is essentially about the SW text frame, is all in this source core text subdirectory, and this is slightly more than 50,000 lines of code. And then the other big chunk is the layout code, which is for essentially for all of the frames which are not text frames, and this is almost 70,000 lines of code, and it's in the source code layout directory. And then there is some additional code. For some reason, it's in a separate object positioning directory. And yeah, this is not much. Okay, and how is the layout code usually invoked? So the most common way to invoke the layout is via the SW lay action class, which contains some code to set everything up and to iterate over all of the pages, and then to position first all the layout frames, and once that is done, it will call the text formatting for all the text frames, and so on. Until everything on the page is valid, and then it will continue with the next page. And there are two common ways how this lay action is created. First, via the view shell end action function, which is called basically every time the user does some sort of edit to the document. And then there is also the VCL event loop, which at some point will have nothing important to do, and then it will invoke the SW lay idle, which is an idle task that, among other things, like it also does document statistics and some things like that. Among other things, it will create this SW lay action. Right, and then there are some other places that can start layout or text formatting. For example, there is the function SW text frame get formatted, which usually does nothing, but in case the frame on which it is called is not yet formatted, then it will actually do the formatting, and this may or may not give good results. So it's a bit suspicious if you see this invoked and it actually does formatting. Yeah, then there's another case which I've seen in the past, but I hope I won't see it again. It's possible that you have already an SW lay action on the stack, and then through some mysterious indirection, another SW lay action is created while the first one is still active, and this is never a good idea, and it will always result in trouble. Right. So, and then there are a few more parts here. Once the layout is finished, we actually want to get it visible on the screen, and there is the painting code for this. So for the layout part of it, it's in the file layout paint from.cxx, and for the text formatting part, it's mostly in the file text from paint.cxx. And as you can see from these examples, writers always followed all best practices in terms of naming things. Yeah, and how is it painted? Mostly via the VCL output device API, which has existed since a long time. Except there are some parts, such as the shapes, drawing objects, and a few aspects of the writer layout frames, such as borders and background fills, that are already painted via the more modern drawing layer API. Of course, in theory, everything could be painted via drawing layer, but yeah, that remains to be done in the future. Right, and then there is also the PDF export, and PDF export is basically painting the document with some extra steps. So for PDF export, the actual painting happens onto a VCL meta file, and then this meta file is converted to PDF. And there is some additional things being put into the meta file and attached to the side of it somehow in a rather hacky way. And all of this stuff is in the file text enhanced PDF export helper CXX. And that way you get things like a table of contents and a structure tree for accessibility in the PDF. Yeah, and all of that stuff is also generated during the painting. Okay. So now a bit more about the connection between the writer core document model and the view or layout. This is a bit of an addition to what was mentioned already by Miklos in the first part of the talk. So in writer, we also have these sections, and there are there's, of course, as you might expect, an SW section frame that is used in the layout. And this sector frame is a flow frame, which means that it can split across pages. And as you might expect, similar to a table or a paragraph. And there are a few very odd things about this section frame. For example, you can, in the document model, you can, inside of a section, you can create another section, so you can nest them inside of each other. And in the document model, yes, they are properly nested, the nodes, but in the layout, you do not get nested section frames. Instead, when the inner section begins, the outer section frame ends, and at the same level, you get the inner section frames, so you get a flat sequence. And this also means that a section can have multiple master frames, even if it's not in a header or footer, which might be surprising. Yeah. Then the section may also contain columns. And in that case, below the section frame, you will find column frames as the children. And inside each column frame, there's a body frame. Whereas if there are no sections, then the content of the section is directly as children of the section frame. Yeah, another peculiarity is that as layout frames become empty during the layout, typically they are deleted immediately. But for section frames, this is not true. The empty sector frame remains in the layout tree. And at the end of the SWLA action, there is some garbage collection for the empty section frames. At that point, they are deleted. And that means that a lot of code which iterates over frames has to take into account that there may be an empty section frame, has to skip over it. Otherwise, you will get surprising bad results. Yeah, so much for sections. So now let's talk a bit about the merge paragraphs, which we now use for delete red lines. So if you have a tracked change, which is a deletion, then in the old days, that would actually, when you toggle the view settings that you want to see the track deletions or that you want to hide the track deletions, in the old days, that would actually modify your document model, but we don't do that anymore. Instead, now the layout and the text formatting hide the delete red lines. And in order to do that, we use this data structure here, the merge paragraph. And this consists of first a multi-listener, which I will explain on the next slide, and then a vector of extents. Essentially, this is integer indexes into the text nodes, which mark all of the parts of the paragraphs which are visible. And yeah, as you can guess from the term merge paragraph, you can of course start your deletion in one paragraph and then end it in another paragraph. So you effectively get a single merged paragraph out of multiple document model text nodes. Right, so the extents vector contains indexes for the visible parts, and then there's a string with the merge text, which contains only the visible text from all of the participating text nodes. Then we need a few pointers to text nodes. So the para properties node is used for the paragraph properties of the merged text frame, such as margins and things like that. And then we just have the first node, last node that is self-explanatory. So how does the multi-listener work? So we have here in the general case now, if you have a merge paragraph, there can be, previously there was, the text frame was only associated with one SW text node, but now it can be associated with multiple SW text node. And the association or listener relationship is implemented via SW client in the SW text frame, which is listening on the SW modify of the text node. And the SW client can only listen on one text node at a time. And for that reason, we need this additional writer multi-listener object, which is essentially a level of indirection, so that the multi-listener collects all of the events that are sent from any of the text node and forwards it to the single client implementation in the text frame. And of course, as usual, if the text frame doesn't fit on a page, you get multiple text frames, each of which has this multi-listener set up. So we have now an M-to-N relationship between text nodes and text frames. So a few more details about how this works. So on the left-hand side, you see there is a text node which has this string containing the contents of the paragraph, and there are these 4 deleted characters in the middle. The right-hand side, you see there is a text frame with this merge para object. And here in the parentheses, you can see the extents for this example. It's a very simple example. There is only one text node, and we have visible from index 0 to 3, and then again visible from 7 to 11. So yeah, a very simple example. And then the merge string is simply without the deleted part. And then we have two different kinds of positions or indexes. For the text node part, we use SW position, which in this example points between the B and the A. And the same index in the text frame is, of course, a different one. And we use a different type for this, the text frame index type. So there needs to be mapping functions that use the information in the extents inside the merge para object to translate between these two different kinds of positions. This is required in very many places. Okay, that's the most important thing, I guess, about how the merge paragraphs work. So far, at first, we have only used the merge paragraphs for deletion red lines, but eventually new requirements came up. And these turned into more use cases for the merge text frames. So you have already heard in part one how writers' own text fields are handled by the text formatting. But it turns out that Word has a completely different model of fields. The way fields work in Word is that in the document model, there are three dummy characters. So there's one at the start of the field, there's one at the end of the field, and there is one in the middle. And the middle one separates the field into a field command and a field result. And these fields are very powerful. So in the field command, you can put anything. You can put paragraph breaks there. You can put a whole table in there. You can put a nested field into it, which is actually quite useful in practice for conditionals and things like that. Yeah, and of course, this is very different from how fields usually worked in Writer. And we already had an implementation of this in the document for a long time. This is called field marks. And the way it works in Word is that you have a view setting so that either the command of the field is shown in the document view or the result. And now, since a couple of years, we can do the same thing in Writer using the merge paragraph implementation. This is actually was done in a bit less time than for the deletion red lines, so it's maybe not as consistent as it was for red lines, where we took a lot of time to guarantee that it's producing the same results as the old implementation for hiding red lines. But this is possible now. And another thing that was added recently is that in Word it is possible to format the paragraph break character with character formatting to hide it. And what Word does then is it effectively merges the two paragraphs together. So you get in the document view, you get a single paragraph. And this is now also implemented using the merge paragraphs in Writer. So we have three different things now that use merge text frames. And there are three different view settings to control these things. Okay, next topic. Now we need to look at the draw page. So in the SVX module, there is this drawing model with all of these shapes and so on, SDR objects. And the way this is displayed by the applications, it's used in all of the three major applications, and the way it's displayed is quite different. Because so in Draw and Impress, you have at the model level, you have explicit pages. So it's very simple. There is one SDR page per model level page. And in Calc, it's kind of similar. There are sheets in the document model. And if you look just at the screen, then a sheet is essentially the same thing as a page. So it's handled similar, one SDR page per sheet. But in Writer, it's quite different, because the document model is just a single document body. And you have below the root frame something very, very dynamic that you can't really predict ahead of time. And so what was done there is that there is a single SDR page for the entire document, and every visible SDR object is on that SDR page. There is some special handling for headers and footers, because you often have images inside of the header, and the header, of course, occurs not only on one page, it occurs multiple times in the document view. And this is currently done so that on the first page where the header occurs, the real SDR object is on the draw page, on that page. And on the subsequent pages, there is a virtual drawing object. There are two different ones for the SVX shapes and for the writer fly frames. Such a virtual object is then put onto these subsequent pages. And this virtual one is essentially a clone of the real one, and it forwards certain calls, but not all of them, to the real object. So this kind of works now. And why do we need a single SDR page for Writer? Because all of the drawing objects have a Z order. That means if any two objects would overlap anywhere, then you need to know in which order do you paint them. So one of them has to be on top of the other, and this has to be consistent. So during editing, the objects will move around. They may move from one page to another page, and during all of this editing, the Z order must not change. And the easiest way to ensure that for all objects is to have a single draw page. Because there have been some complaints about this in the past, there might be an idea how we could do it differently. The idea would be that we could have a single draw page that is only used by the document model. It does not contain virtual objects or anything like that. And the only purpose of this is to maintain the Z order. And then in addition to that, we could have one SDR page for every page frame. Currently, there is a big obstacle to that, which is that the SDR object has a single pointer to a parent, and this is typically the draw page. There would need to be some changes there, either some special casing of the document model draw page somehow, or another solution would be to simply for the SDR page per SW page frame once to only put virtual objects on these, so that every object that is actually painted is a virtual object. That might also work. Well, I haven't thought about this in detail. That's just an idea at this point. But yeah, what this would also enable, if every object that's actually painted is a virtual object, then there would be no additional problem, yeah, it would go a long way towards enabling multiple layouts at the same time. So currently, Writer is limited to having only a single layout. It can have multiple views. You can have multiple windows in the desktop application, or of course, if you use online, then every user gets their own view. But all of these views currently use the same layout. So if a user changes the view setting to show or hide red lines, or which part of the field they want to see, then that switches the view for every user. With multiple layouts, it would be possible to improve that. Yeah, but there are some problems in the way here. So these are some obvious ones that I'm aware of. So currently, the virtual objects are only used for the headers and footers. And then there are some funny implementations here, like this get offset function, which essentially tells you what is the offset of the virtual object relative to the real object, which makes sense if you know that the real object is on a previous page. But if the virtual objects are in different layouts altogether, this is not a function that makes sense. Then I found that there is, during the layout process, it may happen that the document model is actually updated by writing items into frame formats of fly frames. Yeah, you can find a few of these with the grid grab. Not every hit of this grid grab is problematic, but a few of them definitely look problematic. Not sure what to do about that. I mean, that cause problems, like one layout does something that sets this format attr and then invalidates the other layout. And the other layout runs and sets the attribute to a different value and invalidates the first layout, and so on. And looks like a bit of a headache. Another thing is that for the merge paragraphs, we have actually a flag stored in the SW node class in the document model. And initially, for just the red lines, this was quite sufficient, because you either show them when it's using, you either show the red lines, then this flag is completely unused, or you hide them, then this flag is used. But we now have three different things, the different settings that control what is being merged and not merged. And a single flag is not sufficient there. So we would need to have some sort of map with the key being the node and all of the flags. Yeah, something like that. And there are also in the implementation, like the split content node function, where when it updates some merged paragraphs, it will actually assert when it finds that there are frames with different settings, which would happen in this multiple layout case. That was just one obvious one I found. But there's a general pattern here of a lot of code was written with loops over multiple layouts and things like that, assuming that it's probably going to work if we're an optimist. But in practice, in many cases, there will be issues. So it's yeah, this is not something that can be done very easily, I think. And of course, what's completely unknown is what would be the performance impact of having multiple layouts, and also the memory impact, I guess. And a related question is, how many layouts will we actually need? Do we want to have one layout per view, or maybe would it be better to have one layout per combination of view flags? And then if the user toggles a view flag, then we could switch from a layout that they're currently seeing to a different layout which has the correct flags and so on. Yeah, many unknowns here. Okay, so much for speculation. Now we can get back to some more basic things and general points about the layout. And yeah, a reminder for myself that I need to watch my language here. Yeah. So compatibility is very important for the layout. The first obvious thing is that from a user point of view, if they create a document today and store it, and then they load it 5 years from now in the then current version, they want that document to look exactly the same as when they stored it. And if it doesn't, that's a bug. On the other hand, users also want to load some documents which were created in Word, and in that case, they want the document to look exactly the same as it did in Word. Now, of course, historically, writer's layout was doing things differently than Word has done. And yeah, then another thing is that the standards for ODF and OXML don't completely specify everything detail about the layout. For example, in the paragraphs have spacing above the paragraph, below the paragraph. And historically, what writers always done is the spacing between two paragraphs is you take the spacing below of the first paragraph, spacing above of the second paragraph, and the interparagraph spacing is then the maximum of these two values. Whereas Word, it simply adds these two spacings together. Of course, this can create big differences. But yeah, as far as ODF is concerned, well, we don't know what's correct. So both are correct. And as a result of all of these compatibility issues, we have in the layout code and the text formatting code about 70 different compatibility flags that all have to be taken into account, and they, of course, add additional complexity to the implementation. And these setting flags are actually stored in the ODT documents in the settings.xml. So that way we can maintain layout if you have created this document in a 15-year-old buggy version of OpenOffice.org, we can display it exactly as that old version did. Right. So, of course, no, you may ask yourself, oh, I've got this layout bug, and there's this more than 100,000 lines of very complicated code. How do you go about debugging that? Yeah, that's very difficult because the first thing that you will find confusing is that there's the state of this whole layout tree is actually very, very complicated. There are lots of member variables everywhere, and you don't really know what is a valid state and what's an invalid state. And you really want to know when does it go from the valid state to the invalid state, at which point. So yeah, that's difficult. It's still difficult for me when I debug some problem. Often takes a long time to figure that out. Then another thing you're going to notice is that if you build it with debug logging, as I guess you should when you want to debug something, then it does print actually quite a lot of warnings, and you don't know well, which of these warnings are about real problems that you should investigate and which are just noise, basically. Obviously, not all of them can be about real problems, because just look at how many warnings it prints. It can't be. Yeah, so that's also only moderately helpful. And these two first points, I think the consequence of an anti-pattern that is basically spread all over the layout and text formatting code, which is it really tries very hard to avoid crashing. So if it wants to access some object that it really needs to do its job, and the object is a null pointer, then it just ignores that and continues. And the result of that is not going to be good. And you are going to need some time to find the place where it did that ignoring of the obvious problem first, before you can figure out the root cause of it, because it's going to produce a wrong result much later, or it's going to crash like much later, who knows. So this makes debugging more time consuming in any case. Yeah, another big problem is that it's often quite difficult to actually reproduce a bug. If you're lucky, you can just load your document and see the bug. But sometimes it happens that, well, the bug only happens on Windows, doesn't happen on Linux. The bug only happens if you have this particular font installed. The bug only happens if you use the command line convert to flag to reproduce it. It doesn't happen if you use file open. Or maybe the bug only reproduces if you use the unit API to load the document. Or maybe it's very frustrating. Yeah, just recently I have one which only reproduces on Windows and only reproduces if you open the file via by clicking on it in Explorer. It doesn't reproduce if you use file open to load the document. And on top of that, it doesn't reproduce on my Windows VM. It only reproduces in other people's Windows system. Yeah, this is all very funny. And yeah, then you say, oh, I want to create a unit test for this, but if I cut anything out of this 200-page document, then I don't see the bug anymore. So loading large documents in a debug build of Writer takes a very long time. It's quite possible that you need half an hour of CPU time until you get to the point where the bug is visible. And yeah, you really don't want to add a unit test that takes half an hour of CPU time. That's not practical. So yeah, I've certainly had to omit unit tests in when fixing some bugs, which is also frustrating. Yeah, so what bugs can you expect in the layout? No, the most important categories are basically, yeah, you see a wrong result. Maybe something is in the wrong position, or something is cut off somewhere, not visible when it should be. It's wrong size, and so on. Another common kind of problem is that it just crashes somewhere. These tend to be the easiest ones to figure out, although, yeah, easy in layout is always relative. And then a very large category of bugs is that the layout somewhere goes into an infinite loop. Or just does the same thing over and over again without ever coming to a result. And the main causes of loops are the tables. They are very complicated. They're split across pages and then they join again and so on. There are also the anchored objects which can be positioned somewhere on the page quite far away from where the anchor is, and they can also move between pages, and then the anchor paragraph moves back, and then they move back, and then it still doesn't fit on the page and moves forward again. This sort of loop is also kind of common. Footnotes are kind of similar to anchored objects in that they take up space at the bottom of the page. So when you have a footnote on the page, the available space for the document body shrinks, and then you move the footnote to the next page, and then you have more space on the first page again, so on. And in order to mitigate all of these loops, previous generations of writer maintainers have added a whole bunch of hacks everywhere that essentially do iteration counts. And if we went through this loop 20 times and we still haven't finished, then we just quit. We just return and hope for the best. And that really isn't terribly good strategy, it turns out, because very often what you get then is a wrong result of the layout. And it would really be better to fix the root cause that causes it, to simply do the same thing without finding a solution to all of the constraints. So usually something really has to be moved to the next page and can't move back, something like along those lines. Yeah, so that was enough for that. Yeah, so how do you actually debug this? In case I haven't discouraged you completely yet. So one thing that's very useful is the XML dump function on the root frame. You can call this dump as XML with a null pointer, and this will create a layout.xml file in the current directory, and then you can look at the whole layout in a rather simple format. You can search and so on. And you can also, very important, invoke this function from within GDB, so you can step through the code and dump it at various points, and then see, then compare the dumps when has the thing that you are interested in changed and so on. And you can also compare different versions. Say, for example, you have a regression bug, and you can then get a dump from the old version where it worked, and then get a dump from the new version with a bug, and you can compare and see where things different. So there are a lot of uses for this. Unfortunately, I don't know if you can invoke this from within Visual Studio Debugger. That would be very useful if somebody knows how to do that, but I don't. Then, yeah, the SW frame base class has a frame ID member. This is basically a counter. So for every frame that is created, it increments the counter. And you can use this, which is of course also dumped in the XML file. You can use this to compare very easily the different XML dumps. You can find things easily with that. And what I usually do to debug a layout problem is I add some additional Stahl debug printfs, essentially, in the interesting classes. Like if I know there's a table involved, add something at tab frame, make all at the start and at the end, and so on, and the split table function and so on. and then I use the record replay debugger to record the writer execution and reproduce the bug and redirect of the debug output into a log file. And then I can see in the log file, for example, if there is a layout loop, there is going to be a list of debug printing that repeats itself in a pattern. And in that way I can find loops, and then I can use the replay to debug the recording in GDB, and this will also print the same log output, and that way I can orient myself to find where to start investigating the layout loop based on the log file. And yeah, it still takes quite some time to figure out these problems, even with all of the tools we have. Yeah, and that was all from me. Okay. Also, thanks for your attention in case you're still around.
Thank you, Michael. We'll start with the questions. Questions, guys. Balaj, Baron, Kalen.
Yeah, for me anyway, I suppose one thing I was curious about is in footnotes. We never seem to support tables in footnotes, but we do support tables in footers and headers. Is there a fundamental reason we never enabled that, or is that just hiding some bug that never got fixed?
I am not aware of a fundamental reason why that wouldn't work.
Yeah, I know you can't do it.
I guess it's just some bug, and I have a vague memory that actually there is a way to get tables into footnotes. I think one of the import filters is able to do it. I'm not sure how, but maybe they forgot to add the code that disables it in that import filter somehow. Something like that.
And then the other thought that just occurred to me, and you mentioned about how the layout, special, the various hacks in the layout, would it be anywhere useful to have a mode where all of the historic hacks were disabled, and then use something like Fuzzer to try and generate the smallest examples that trigger the problems, and try and have a look at those original fundamental reasons from scratch? Does that make any advantage there, do you think?
I don't know. I mean, there is no shortage of problem reports, so it sounds like you want to find additional problems, but
No. What I was hoping was if you require massive documents that take half an hour to generate layout issues, I just wondered if things could be simplified by throwing fuzzing at it and trying to generate very, very small cases that might,
possibly. I mean, you might be able to get documents that are easier to debug that way, but the problem is that you then have no idea if the bug which you are fixing has any relationship to the bug that that the customer wants you to fix, essentially.
No, that's fine. I've got nothing else. Thanks.
Thanks, Kalen. Gokai, Jaume. Oh, Mike. Ask.
I just wanted to tell that yes, there are problems that even when you have the original buggy document and you try to minimize it, that Mikhail already mentioned in the talk, I ran several times into situations when I got a nice minimized document which had exactly the same problem as the original one. I fixed it. And then it turned out that in the process of minimizing, I introduced another problem and fixed it, which looked identically but was different. So it is already quite complicated. Thank you very much, Mikhail.
Thanks, Mike. Justin, Mevin, questions? Okay. Mohit,
No questions. Thanks, Michael.
Mohit. Okay. Moritz, Neil. Thank you. Parth, Sahil.
No questions. Although I saw that GDP statement and I was immediately triggered because I was looking into GDP yesterday. Yeah, thank you.
Okay. Yeah. Stephen.
Yeah, I have one question about this what's para thing. Michael, you said the first and last members, or what they're called, would be self-explaining, but they're completely not to me, because one is a pointer to const, as you would expect, and the other one is a const to pointer, non-const. And I thought there would be a typo on your slides, but when I look at the actual code, it is like that even in there. So this looks rather confused to me. Or is that just normal writer style, maybe?
Oh, what I actually meant is that the name of the variables is self-explanatory.
Okay. Yeah.
Why one of them is constant, the other not, is not something I can answer on the top of my head.
All right.
Thanks, Stephen. Miklos, any questions?
It's more just a comment. First, thanks for pointing out that section node versus section frame mystery with nesting. That's some catch that I was not aware of. So I learned something. That's good. Yeah, the other is this tables in footnote thing. I guess one trouble there is footnote content would be similar to paragraphs or tables. So it would be a normal, ideally a flow frame where you can split that across pages. And with the current implementation, they are not a flow frame. They have a manual master follow tracking and. So like what is there for paragraphs and tables as shared code and the good notes is not there for footnotes. So with this more or less working but not ideal state, adding the complexity of tables would probably quickly fall apart. So that might be one reason why the UI to create this structure was the same one. That's it.
Thanks, Miklos. Yeah.
Oh, that's a good point.
Okay. Thank you guys for joining. Thanks, Michael, for the presentation, and see you guys next week. Bye bye.